In addition to talking about setting up a Rhino site model for environmental analysis, we also introduced two climate um, analysis programs that we use, Climate Consultant and Climate Studio. And in addition, I covered a lot of background material in a lecture. So let me just remind you, in Canvas, every week there'll be a week's module. In this case, I'm not even gonna, this site model is from last year. I wouldn't even look at it. You can if you want to, but so let's just, I'm gonna open up the slides, remind you how to access them, and then I'm gonna open it up in PowerPoint. There's a lot of information here that's absolutely necessary if you understand how to do the environmental analysis that we're starting to do. You'll remember that the decision has been made. That I've made the decision that even though we do have readings, I don't know how to get you to do them, and just based on experience, you're busy. We're not quizzing you on these. This isn't more of a design-based class, so I've decided to try to get the information across to you in lectures and provide then links and things in the lectures themselves. So if remember, if you see a screenshot, it's probably going to have a link in it. So if I do it from this slide, that will take you to the site that I was talking about in class, and you can play with that around with it yourself. So my point is you need to understand these basics. This is not something that you're going to get instantly, though. So don't be discouraged if you're like, I don't really understand yet. I was listening. I tried my best. That's why you got to ask questions though in class and keep coming back to me. We'll be using this information all semester, and throughout your career, you will be using all this information if you're doing conscientious design, because the environment, the climate around your building is the sort of the most basic set of variables and information that you use, or that's is going to affect your building and your design. So I'm going to start by just talking some about Climate Consultant, just reminding us how it works, and maybe occasionally going back to the slides, do this little quick review to remind us what we're actually talking about. So Climate Consultant is a climate analysis software, macro climate, whereas Climate Studio in Rhino is more focused on the microclimate. So Climate Studio, to me, is more resilient, or more, it gives you more options, and you can use it for a longer period in the design process. But the Climate Consultant is still a very good resource, especially to learn about climate, because it's basically a book. So you'll see if you come in here, there's a lot of information on the first page. Tells you about where you can find EPW files, which we talked about, which are the climate files. It talks about the psychrometric chart, and that there's information available to understand how it works, etc. So for example, on the next page, if I'm just clicking through, there's a psychrometric chart tutorial on this page. So there's a lot of information in this piece of software, which is just really sort of like a book that's tied to climate data. Remember that if you're doing this for the first time, you'll start a new project. Once you've got something, climate data in here, then you can just, when you open again, it's going to ask if you want to continue your previous session, because it's going to know where that climate file is. You should start saving climate files that you think you might use, definitely New York City, at the different versions, the different, we've got Central Park, we've got LaGuardia, and other local climate files that we can access. It's good to know where they are and have easy access to them. Anyway, so I'm going to start a new project. We are in Imperial or IP. We're going to download a new EPW file. If open existing weather data file would be if we had them on our computer already. I'm going to go install from the weather data site. There's instructions here. It tells you to copy the link. So I go through this quickly, but you should always go back and read if you're confused. And so now we have a map of the world. So the assignment today is to pick a New York climate file. So you'd come in here and pick one from New York City, and then you can use this map to find a climate anywhere you want. It can be somewhere else in the United States. It can be, and as you zoom in closer, you get more and more files, more and more There's also other places to find data, EBW files or TMY files. Climate Studio is one place to do it. So if you want to find a climate somewhere that you can't find quick, you can't find in the resources you have, let me know and I'll help you find it. If I zoom in then to one of the New York, so let's say I'm going to do Central Park. I'm going to select it. Actually, it's over here. It's these little teardrops is where the actual climate file is. I am going to click on the EBW file. Actually, I'm not going to do that. I'm going to so you right click on the data file. I'm sorry, you mouse over to get these different files. There are options. We want the EBW. I'm going to right click on it, copy the link. So I'm copying this link, going back to my climate consultant tab or page and paste the link into this dialog. Then that will install it. I hit install, and now I have my climate data here. This is the summary page. Well, as we go through this, we'll start talking more about units. Right now, this is just, we can think of it as a relative. I mean, BTUs per square foot, we haven't really described. We have metric and IP units that we'll be using or seeing, and we'll talk about it in more detail when we need to. But let's go over the basic charts again. I did this in class. Remember that there's a lot of information here about, uh, for example, this is the summary page. We can pick different comfort models. We can set specific criterion for how we want to display the material, the data here. So there's a lot of things we can do with this. I'm trying to point out that this is a tool you can use and fine tune. Let's look at charts though. So this first chart, if you were listening to the lecture, then you'll see why I gave the lecture. So for example, we have down here. So this is a temperature range chart. We're using the California Energy Code, and like I said, we could have set a different. We could use ASHRAE 55 current handbook. Let's just switch to that just for see what happens. We're using ASHRAE. So I'm not going to even tell you which one to use. Just make sure you use the same one for all the climates that you're comparing, or your two climates that you're comparing. So the first thing we see down here, though, is its temperature range. We've got temperature in Fahrenheit on the y-axis, and of course the months on the x-axis. The gray area is the comfort zone for humans, and then we have an average temperature in the middle, which is the band. Average high at the top of the yellow, average low at the bottom, and then the design high and low is at the top and bottom of the green. So let's talk about what is the design high. So you see right now we've got it selected on 1% for both high. No, actually we have 0 and 1, so I'm going to go back to 1% for both. And you'll see that then we have a high temperature and a low temperature that's not within our range. Remember we said in the lecture that we do this because if we're designing if we're doing an environmental design for a project, either passive or active or both, we're not going to probably design the full building and the full systems that we're designing for the worst case scenario, because it might just be, in this case, 1% of the year. Do we really want to spend the money to go, if it's, it might be a drastic difference, or it might push us into a design that would be more costly and inefficient over the long term. And so we might pick a secondary strategy. So for example, in April, we might just say, you need to wear a sweater, or we're going to have some kind of secondary heating or cooling system, in this case, heating system, that would allow us to just punch in a little bit of extra heat at those few hours that we need it. So anyway, that's what the design high and low are, and if we set them to 0, you'll see that there is no value above or below the range that we're choosing. That's because we're using the entire the full range of the temperatures for that climate. So the point is here, this is a general way to look at if we have more heating or cooling requirements. Is there certain months that are, we really have to be concerned about because that might we might want to focus on. For example, it's looks like it's a little colder in February even than January. We might want to make sure that we're getting heat gain from the sun in February, and we can look at that month specifically in other simulation approaches or modeling that we do, for example, in Climate Studio. Okay, so anyway, this is just a chart that shows you temperature ranges. Let's keep moving. This diurnal temperature range is very powerful. We had some examples of this in the lecture. Maybe I'll go show those in a second. First of all, we can turn on or off the full range of dry bulb temperatures just to make it clearer. So this is basically saying, in January we have this range from close to zero to oh, this is radiation. Right, so this is a double y-axis chart. We've got radiation on this side and the temperature on this side. Um, so we're saying that, in January we're going from 10 degrees Fahrenheit to, well, I'm looking at January. Let's just look at December. It's easier to, because this is where the range is. We're going from maybe 18 degrees to above 50. So there's a big range, but then if we take the mean, the average, we get these lines. And so let's go over all of these inputs and talk about them in a little bit of detail. First, let's see. Let's start with the dry bulb and wet bulb mean temperature. I'm going to go, you remember we talked about, we went to the Andrew Marsh psychrometric chart. There's actually a psychrometric chart in Climate Consultant, but I think this one's easier to use because we can turn things on and off. So I'm going to open it. Here we are. I'm going to bring in the same basic weather file, New York City. I'm going to get rid of this overlay for now. Overlay. I'm going to, let me just clear this out first. Okay. So if I bring in my dry bulb temperature, that's in the x-axis is dry bulb. Absolute humidity is the y-axis. Here. And then relative humidity are these curves, 10, 0, 10, 20, 30, 40, 60 to 100. And then if I bring in wet bulb temperature, that's why I'm bringing this up because we can see the relationship between these. And we talked about this in the assignment, or I'm sorry, in the lecture. Remember that, and I want to change this to, I want to change the units to Fahrenheit. If we start, and I'm going to turn off the overlay for now. If we're at 70 degrees and 10% relative humidity, we follow this line and we have a wet bulb temperature. So the 70 degrees is our dry bulb temperature. Then 47 degrees is called the wet bulb temperature. And that's a way of just relating with one number the dry bulb and the relative humidity. And the point is, as we get higher and higher in humidity from the 10%, moving up with the 70 degrees. So for example, if we're up here at 80% relative humidity, our wet bulb is 66 degrees, and if we're at 100% relative humidity, it's going to be 70, the same as the dry bulb. So if we go back to our climate consultant, the point here is that then this is a quick way of getting a general idea of the amount of water in the air in the climate at during the different months, because we have the red up here is the dry bulb mean average temperature, and the brown, I guess, is the wet bulb. And so how close these are to each other is a general indication of how wet it is during that month. It's easier to see this if we go and do a comparison. So let me go back, let me go to the slides and find these particular slides. Sorry, I'm not exactly sure. Here it is. So we're going to compare New York City, Phoenix, and Mobile, Alabama. And one point to make here is that Phoenix and Mobile, Alabama are not that far apart. It's just that one is in the desert and one's in a very wet part of the country down by the coast. And so if we look at these, let me expand this. So in Phoenix, we see that we have a pretty wide, especially in the summer, like the difference between the wet bulb temperature and the dry bulb temperature is extreme, and that's because there's very little water in the air. Also, we don't have that many clouds, which is what the diffuse one way to interpret the diffuse radiation, which is the blue. We'll talk about that in a second. Um, in New York, for the same month, much closer, so we have more water in the air. Um, but then if we go to Mobile, we'll see in general that they're much closer because Mobile's very wet. Um, and Of course, it's different for different months. But for example, if you look at December here, actually, sorry, I don't know how that happened. Um, a very different profile in dry bulb to wet bulb in Mobile in December than in New York City and then in Phoenix. So it's a way of quickly comparing climates rather than looking at big tables of temperatures or the psychrometric chart. We have these ways of summarizing. Let's then go over the rest of these variables that are on this chart. We'll just stay here. Um, so remember, actually, let me go back to earlier in this. Here we go. This is good. Remember that we were saying that we have several um, variables in terms of the sun coming in and hitting our surface, whatever we're talking about. The the most basic metric is called direct normal, and that's we're saying if we wherever the sun is pointing, whatever angle it is in the sky, we have a surface that is pointing directly at it. So in other words, the rays of the sun are normal to that surface. It's perpendicular to that surface, and that tells us the amount of energy that's actually coming in. Um, then there's going to be some sun. It's going to be cloudy. There's going to be other reflections, water, whatever, and we'll have some direct horizontal radiation, which is what's bouncing off of clouds you can think of. Um, so those two together create the global horizontal, the total, except that the direct normal has to be adjusted for the where our actual um, the surface that we're talking about measuring. So if it's the ground or a wall, we have to derate it based on the angle it is to that surface. If that's confusing to you, we can talk about it more. I talked about it in the lecture. I don't want to spend a lot of time on it. But it's a way of understanding these charts. Um, we go to that comparison chart down here because let's see if we can decipher some of this. So first of all, here we are in Phoenix. We know it's going to be not very cloudy in Phoenix, and so um, we're going to have um, a lot of direct normal and less diffuse because it's not very cloudy. Also, because it's not very cloudy, our total global is typically going to be closer to our direct normal because we're not losing as much um, to clouds. But also you'll see that so why in January here is our direct normal more than the global horizontal? That's because the sun is at a pretty big angle to the surface that we're measuring. In this case, this is the ground, um, and so because the cosine of that angle is larger, it means that the actual global horizontal, which is the um, direct normal times the cosine plus the diffuse, um, will be lower than the actual amount of direct normal coming in. Again, if that's confusing, okay, just start looking at these charts, trying to understand it. Talk to me about it. We'll go over this in class again when we're looking at your assignments. It's not completely straightforward to understand, and so it takes a while. So I'm not wouldn't fault anybody for being confused, but you need to slowly start learning this like we learn anything to where it becomes second nature and you can use it when you're looking at different situations that you're dealing with in architecture. Okay, so we've basically covered then this chart, what comfort zone, which is gray, wet bulb, which is the dry bulb is the one at the top, the red, wet bulb is the brown, global horizontal is the green, direct normal yellow, and diffuse horizontal is the blue. All right, let's go back to um, climate consultant. What else we got here? Radiation range. This one, the main thing to point out here is that if we change, this is a way to start thinking about understanding that cosine thing I was just talking about. Right now, we're saying that let's say in January in New York City, this is how much sun's just coming in. And again, if we had a piece of glass or a mirror or whatever we're using to measure to hit for the sun to hit, we would face it. If it's winter and the sun's low in the sky, we're going to point it directly at it. This is how much sun would be hitting it. Um, but then these two, the global horizontal and the total, and this is actually not total surface. This is, if you look in the help, it's actually tilted surface. So this is a typo in here that's very confusing. So this is supposed to be tilted surface. Um, we'll see that. So here, since our tilt down here is 0, so this means we're looking at the ground. Then we've got this is January. We're like in this. If we go back to here, we're at 41 degrees. If you go back and look at I think it's in last week's slides when I did that. No, yeah. So if we're looking at New York, right, and this is the winter, in New York. We're at a pretty severe angle to the sun. The rays coming into the sun. So we've got, in terms of the cosine, it's going to be like, I don't know, 0.5 or something. I can't remember what the exact number is right now. And so this number here of the direct normal is going to be cut in half or so, which is what the gray is here, or this light orange. So the main thing to understand, so and you can look at that and see how that's always the case, that until the sun starts getting higher in the sky, the global and the tilted are lower than the um, the direct normal. But now, let's say if I come in and I put a 90 degrees on it as a tilt, 90-degree tilt, um, you see that this changes quite a bit, because now we're saying that we're looking at a wall which is 90 degrees to the ground. So the sun hitting that wall, a lot of the energy is hitting at almost normal. It's almost at the angle that the sun's pointing at. And as you get into the summer, it's actually much less sun hitting that wall, or probably a window is what we're more concerned about. This is a really important basic understanding about how the sun works, because whereas when we're talking about the ground, it looks like in the winter when it's cold and we would like more sun, we're not going to get as much as we do in the summer. The actual point is if we're talking about a horizontal wall with a window in it, it's the opposite. And so we can use that to our advantage. It's a very powerful technique that humans have used for a very long time to heat buildings in the winter and cool them in the summer by blocking the sun. All right, so again, could be confusing. We've got other stuff going on in here that I'm just going to skip for right now. But these charts are good to look at and study. Illumination range. Oh, that's right. So some of these don't have an illumination range. If you go find, let's just go to and I think that's just a function of that's not in the climate file. Maybe it's a different, so it's just good to know. Don't worry about it. But here's one. The illumination range is really similar to, it has the same variables as for heat or energy from the sun. It's just that we've talked about this in class, that you see there's only certain wavelengths coming in of energy coming from the sun that we see, and we have to consider how our eye sees them. So it's just a different metric. So let's not really think about that too much right now, but we will get into it later. Um, what else we got here? Sky cover range, this tells us something about the cloud cover. Now, again, we're just looking at a single climate right now, and the point of your assignment is to look at two different ones, one that's quite different. So you're going to want to, it makes much more sense when you're looking at these charts when you're comparing them. So you would have another file that you would download. The best way to do it would be to do screenshots of all these charts for both climates, and then look at them together and try to make some conclusions, some basic conclusions. Is it sunnier in, one climate than the other? If so, can you dial in a little bit more? Is it really sunny in the winter or in the summer? And what could that comparing both climates in that way and finding some kind of nuance. Maybe in one it's much sunnier in the winter and cloudier in the summer, and the other it's the opposite. But then one of them is a hot climate and the other is a colder climate. So you have to think it through. So it's a very straightforward chart there. Uh, Wind velocity, same idea. Ground temperature, we talked about a little bit. The idea being that the ground changes temperature more slowly than the air. And so it's a more stable environment, first of all. And uh, we also need to know how deep we have to go to get to the frost line, because that's how we determine how deep our foundation needs to be placed. So again, lots of things we can talk about there, but that's just the point of that chart. Here's a relationship between dry bulb temperature and humidity, which is something you should study and learn about. We've talked about that in class. Same thing with dew point. I would skip these sun shading charts. I don't think they're that useful because we have something much better in Climate Studio. Uh, Psychometric chart. We talked about this in class. The real advantage here is that in this, you can change, you can make it hourly, daily, max and min in terms of the climate data. I mean, each of these dots is an hour of the year, and so it's just saying what the temperature and relative humidity is for that hour of the year. And our goal is well, when we're designing a building, we need to get all those dots inside this comfort zone, which is in this case the blue. This blue range is set by whatever we created for our comfort model here. And this is something you don't need to really worry about with this assignment, because all of this stuff here is really the content of a lot of the rest of the class. So we're just going to talk about how we get these dots into the comfort zone by using aspects of our building and its placement. So just realize this is here. We're going to talk about it more. I don't think you need to use it for this assignment. You could if you wanted to, and it's a good thing to start learning about, but it's not totally necessary. And then we had a wind wheel. I talked about how I think the one in Climate Studio is better. Okay, so let me see. Just a reminder that there may be some other things in the slides you want to review. I talk a little bit about sort of a clear layout from the psychometric chart. I show some other comparisons of different climate zones, comparisons of wind and things like that. So you may want to look at the slides again to reorient yourself. Let's talk just one little bit more about Climate Studio. We're not doing much in Climate Studio this time, but we are looking at sun and wind probably, which would be a good thing to use. First point. Now we made a model. We're in Rhino. We've got Climate Studio on. I turned on the sun here. We're talking about microclimate now, right? The climate consultant does not deal with microclimate; it's dealing with macroclimate. We're not talking about tree cover or anything specific to the site. It's about the general characteristics of the local climate, of the climate in the area. So, just a couple things here. Just remember that we're in site analysis. That's the workflow we're using. It's the only one that we've opened at all. You turn the sun on and off here. Some people have had some problems with the view settings. I created a video to help explain it. So if you have any problems, just find that video or talk to me about it. But it all comes down to settings here in this in the settings view, CS shadows. There's some ways you can have settings in here that may be defaults for you that will countermand what I'm talking about right now. But here's the basic way this works. You have shadows you can turn on and off. You can turn on this window, solar window that we talked about in class. I'm going to place it somewhere so we can see it, like right here, and I can change its size. So it's adjustable however I want. Maybe that's too big, so maybe I go 250, whatever. This is subjective. But now when I, oops, I didn't do anything. 250. Now when I am moving my sun, it moves both on this solar window chart. You see it's moving down here and here. These are all, like, I can select here, and this is a high quality image I can export, or I can just do a screenshot. I want this always to be an IP, not SI, by the way. I can set the top view. I'm going to turn off my sun path. Well, I'll leave it on. I can set the summer solstice at 9 a.m., noon, and 3 p.m. So it's very quick to do an all-year study of the solstices and equinoxes. One thing that, remember, if this is our site right here, we don't want to be way out here. That's one reason I made a smaller site. I want to be down here and see the actual effect of my microclimate on my building site. And you may not be thinking about a building site yet, but I'm saying that's one of the steps we take. 9 a.m., noon, 3 p.m. for summer solstice, winter solstice, 9 a.m., noon, 3 p.m. Obviously very different. The other thing we talked about was wind. Turn on my wind rows. I'm going to turn off sun for now. Same thing here. If I have the wind, I can set the position. So let me just place it. I'm going to place it right here. And I can change its inner and outer radius. Oops, sorry. You want to look at this down here because we talked about this in class, but we have the colors are the speed, and the length of the fingers are the number of hours that the wind is going in that direction. We made points about this. I didn't show this before in the sun, but we can set a range. So if I want to make, let's say I want to make a summer. Let's see, let's go June through, these cross over each other, June through September, probably a little before June, right? So this would be summer hours maybe. You have to turn it on and off. And then if I switch it over to winter, we have a completely different pattern. We can also set, 9 to 5 if we want to, because it's going to be an office building or something, and that will also create a different pattern. So that's the way that we use the wind. But you also think about, let me go back to setting the position. I'm going to set it down here. We can see that there's a lot blocking, and maybe this is a little hill here that's going to block the wind. Definitely this building is going to block a lot of this wind. These are going to be blocked. This wind's going to be blocked somewhat by these buildings. So it's more complex to analyze wind on a site. And so we don't want to just take these colors and try to make some conclusion. We want to be more nuanced about it. All right, so that's my quick summary that's building on what I said in class. Hope it helps. Let me know if you have questions, and I'll see you next week.